Hi everyone, welcome to MIT Press Live. I'm Katie Lewis, I'm Head of UK and EU Publicity at the MIT Press, and I'll be hosting today's talk. I'm very excited for you to all meet today's guests. Ashley Jean Yeager is Associate News Editor at Science News. She's written for Quanta, Nature, Astronomy, Sky and Telescope, The Scientist, and other publications. She also spent a few nights at the telescope with Vera Rubin herself as she explored some of the largest galaxies in the universe. And of course, Ashley is the author of Bright Galaxies, Dark Matter and Beyond, which we'll be discussing today. Critics have called Bright Galaxies, Dark Matter and Beyond compelling, moving, insightful, excellent, and mesmerizing. So we're very much looking forward to hearing more about Vera Rubin's extraordinary life today. Ashley will be in conversation with Emma Chapman, who is a lecturer and freelance journalist at the University of Nottingham in the UK. The author of her own book, First Light, Switching on Stars at the Dawn of Time. And Emma has a room in her house just to contain her telescopes. Welcome to you both, and over to you.
Thanks so much. We're very excited to be here. I'm super excited to talk about Vera Rubin. She is one of the most incredible people I've ever met and had the opportunity and privilege to interact with. And so I'm hoping that today we can talk a little bit about the book and also talk about Emma's work. Yeah, so I don't know, Emma, do you want to start with some questions or?
Yeah, no, I mean, my first question after that is that how was it meeting Vera Rubin and actually having the unbelievable privilege of observing with her, which I mean, I can't believe how that
was. I still find it pretty surprising that it actually happened at all. The whole story kind of goes back to when I was an intern at the Air and Space Museum and in Washington, DC, and I was working in the Explore the Universe exhibit there and was told to walk around and just figure out what jumped out at me. And so as I was walking around, I was noticing that there weren't very many women in the exhibit. Caroline Herschel was obviously there, but I got kind of closer to the end and I saw this plaque with a picture of Vera and a discussion of her work. And it talked about this thing called dark matter. And I had never even heard of it. I just thought the universe was the stuff that was around us. And that was that. And we knew everything. And, you know, ta-da, that's the answer. And so as I was reading about her work, my mind was just blown that the majority of the universe we do not understand. I mean, it's just incredible that we don't know what it is. And so kind of being a budding science writer, I started to pepper my mentor with questions and he was like, okay, whoa, slow down, slow down. He's like, you know, I actually have been working on an oral history with Vera. Would you want to come and interview her with me? And I jumped at the chance. And I think the thing that really struck me about going to meet her is I was 22, I was a nobody, and here I was sitting with this, you know, eminent scientist, and she was so curious about me, right? She made me feel like an equal. She wanted to know what my goals were, what I was doing, what I was interested in, what I was planning on doing after I did my graduate work. And she just that conversation really made me, I was just in awe of her because not only was she this really great scientist, but she was just a person who made you feel welcome and part of the conversation and didn't just exclude me because I was a young kind of early career person, but really trying to foster my own goals in that first interaction. And I think that's really what made me have the courage to ask her to come to the telescope. And I thought for sure she would say no. And I always like to tell this, I emailed her and she called me immediately after she got the email. And she said, you know, I usually don't let anyone come to the telescope with me, but I'm going to make an exception. And I'd love to have you, but here are the ground rules. And so, you know, we walked through exactly what her expectations were. And then at the end of the conversation and in a follow-up email, she said, okay, make sure you bring a jacket also, because it gets really cold at the observatory and I don't want you to be uncomfortable. So it was this whole gamut of an experience of being with someone who was so meticulous and so focused on her science, but then also had the capacity to say, here are my expectations of you if you are going to do this, but also make sure you bring a jacket so that you're comfortable, and kind of that nurturing side of her as well. So it was like you, in that 4 days that I spent with her, you really saw this whole person, and kind of this whole story, and that this was one of the last times that she would go to the telescope. And her husband was also sick at the time. And so you could see this struggle that she had between wanting to do her research and being so curious about the universe and these very, very large galaxies, but also having that pain of not being with her husband when he was so sick. So I don't know, the experience was incredible. It was like a mini lesson in how to be a good human being, I guess you could say.
Yeah, I was just about to say, like, you got to see the full human being, when normally when people talk about Vera Rubin, it's very 2D. It's, you know, she just popped into existence, measured some stars, showed some wibbly lines, and then we don't need her anymore. You know, and actually what I love in your book is that you don't just focus on that. You know, you wind in her personality, you wind in where she came from, and actually what made her her. And you know, what you've just discussed when she was interested in you, I think that really resonates with how she wasn't interested in being told what to do by the men of the field. You know, she's told, go do this PhD. She says, nah, go see Sal Gamal. And he's like, no, I'm curious about that. I want to do that. And you know, that curiosity, I think, obviously transferred to you. Like, who's she? Like, you know, what's she doing? Ooh, you know, and I think, that must have come across, and she must have found something very interesting. Of course, you are a very interesting human being. Like, she must have found something that was like, no, she's the exception to come up with me. And I love that you also say about expectations, because I think that must have been bred into her over time, or that's the wrong word, but, you know, really, really enforced into her, because there were so many expectations on her. Don't sleep in these accommodations. Don't cross this red velvet line. Don't go in these toilets. So many expectations on her. I'm not surprised that she learned to say, right, you stick with me. And these are my rules. You know, that's really interesting.
Well, and I think it showed just how much she coveted that time being at the telescope. And she was very meticulous and very concerned about making mistakes, or, you know, publishing data that she wasn't ready to share with anyone yet. And so even though she had been observing all that time, she still maintained that ability to kind of compartmentalize all of those things. And it's like, yes, I want you to come, but I also have this very disciplined way of how I like to observe, and I don't want to mess that up, because this is the standard that I hold myself to. And so, it was just fascinating to watch her work in that capacity. And then also to kind of have these little moments where you really did see her being human. I remember being at the telescope, and her collaborator Deirdre Hunter was there, and it was Deirdre's daughter's birthday, and so they got on, I don't know if it was Zoom or Skype, I can't remember exactly what the platform was, but then they both sang happy birthday to her daughter. So you had kind of all of these different moments of being this very serious scientist, and then being a mother and a nurturer. And so I think for her, she really did portray that full gamut of personality, no matter what she was doing.
When you saw her observing particularly, and possibly when you were talking to her as well, did you get the feeling that it had become a day job, where she kind of just turned up, or was it still this kind of, I hesitate to use the word spiritual when we're using scientific discussion,
right?
but something really, you know, that she felt when she was doing observing? She was
I think,
observing, I should say.
yeah, absolutely. I think it was really this deep, like you said, curiosity. She really wanted to know what was going on. And I say in the book, like she looked at each galaxy as if it had its own personality, and she wanted to understand what made that galaxy unique. Like, yes, it did fit in with her larger observation that these galaxies had dark matter and their stars were moving faster than astronomers expected. But what else was going on there that made this unique? And I remember when we were at the telescope, we were looking at two of the largest galaxies in the universe. And she was really curious about finding stars really, really far out in those galaxies to kind of get a sense of what actually happens at the edges. Is star formation there similar to what happens closer in, where you have a lot more material, or is there some other type of mechanism that we don't quite understand yet going on out there? So she always had these questions, and I think that's what kept taking her back to the telescope well into her 70s. And it wasn't just like she was phoning it in. It was, she was very serious about this and very curious and just very passionate about kind of probing as much as she could for as long as she could.
So I'm not sure what the chronology of this, but did you decide immediately to write this book, or is it something that you went on with your life for a while, but it was always there, and it kind of just, there came a time when you were like, now is it, now this is the time?
Yes, I would say it's all very serendipitous. So after I did the internship at the Air and Space Museum, I went on to MIT to do my graduate program in science writing. And in that program, you have to do a thesis. And so when I got there, being young and kind of exposed to all these different things, I was like, oh, I could write about this, or I could write about this, or I could write about that. And as I was talking to my advisors, the thing that I kind of, I guess, communicated most confidently about was Vera's story, because I had met her over the summer. I had spent some time with her. I had done a lot of reading about her work. And they said, well, why don't you write about her? There's been a lot written, so you're going to have to find, other things to include. But, why don't we take that as a jumping off point? And so I did that. And I think I finished that in 2008. And got my degree and moved on to, becoming an intern and then getting my first jobs in science writing. And the thesis was always there, and I had connection with Vera kind of intermittently in those times. I always like to tell people she actually did help me get my first job at Keck Observatory, in that, I said, could I use you as a reference? And she said, absolutely. And so I think, there might have been some discussions with some of the people out at Keck when they were looking for a science writer.
I think one of the best mentors and referees you could possibly have in the astronomy world. That's amazing.
Yeah. And so I didn't think much of writing a book. I was very young, very insecure. I didn't really know what I was doing in science writing. So I didn't have the courage to say, hey, like, I should really do this. And then some years passed, and of course, Vera passed away in 2016. And I was asked to write some obituaries for different publications because I had experience interviewing her. And then I guess about 2 years later, MIT Press approached me and asked me if I would like to write a book about her, in that they had read my thesis. They thought it was very intriguing. They wanted to kind of promote some of these stories of women who had been in science and been very successful, and kind of what made them successful. And so when I got the email at first, I was kind of shocked. I was like, is this real, or is this a joke?
I had that as well. I was like, nah, spam. Went to the copy, and I was like,
yeah. And then I was like,
spam.
Yeah. Well, then and I did. I did what anyone does. I started Googling, and I was like, oh, this is actually real. Okay.
Yeah, I did exactly the same.
I responded from there, and then it took off. So I guess the short answer to your question is the the kernel was always up there, but I needed someone to push me to actually make it become a reality that I would write this book. So I am very thankful to MIT Press for that.
Again, I'm interested because you mentioned as an intern, your mind exploded about dark matter, which mine did too. It's the whole reason I went to university, because I learned about dark matter. I was going to be an Egyptologist, and then I was like, what is this dark matter? And I was like, oh my God, I've got to go to university to learn about that.
Yeah.
And your book, it's got kind of two titles almost. I wouldn't even call that a subtitle. It's Bright Galaxies, Dark Matter and Beyond, the life of astronomer Vera Rubin. And when I saw that, I was like, it's almost two things. And when I read it, it didn't read just as a biography of this great scientist. It actually read as a love of the science behind it, and also a love of the person behind it. So what for you, how did you see it? Did you see, I'm fascinated by the science, and Rubin is obviously the main character when it comes to that? Or was it, this is the character, what is the science behind it? I know that sounds a bit of an ethereal question.
No, that's an excellent question. When I was first thinking about the book, I was thinking of it as kind of a dual biography of Vera and of dark matter. And then the key was, I had gotten some feedback from some people who had looked at the proposal, and the idea was, how do you put Vera's contribution in context, right? Obviously, she was very influential, but there was other research going on related to dark matter. So how does that whole puzzle fit together? And that's what I was trying to do by giving kind of all of that background, is really give an overview of the field, and maybe not as in depth as some people might have liked, but really try to let people know, like, Vera wasn't this unsung hero who did all of this on her own. There was a whole conversation going on in the astronomy community, and the way that she stood out was by being so perseverant and so just in love with her galaxies, and willing to go to the telescope again and again and say, okay, well, I've showed you this data, in Andromeda, you've got these weird fast moving stars based on our assumptions. And, astronomers said, no, it's just that galaxy. And so she would just go back to get different galaxies and go back to the telescope and look at them and try to understand. And I think that's really something that made her stand out, was she did find this ubiquitous behavior of these fast stars in all of the galaxies that she studied. And so it was really trying to figure out, how do you tell that story of the initial inklings of dark matter? And then how do you really show the major contribution that Vera made to this? And what was it about her that made her have the opportunity to provide that major contribution? Was it her personality? Was it something about who she worked with? What were the factors that really propelled her to be able to convince the astronomy community that something was going on out there that we didn't understand?
Yes, and I think by you pursuing all of those threads, as in, was it her community, was it somebody pushing her? That's what I hadn't come across before. I am an avid popular science reader and science reader. Pretty much anything that gets published I read. So I've read a lot on Vera Rubin within books. This is one of the first ones I've come across which is really concentrated on her. And it's the perseverance which I think you managed to tease out really nicely, and how she wasn't afraid of, as I've said, going to Gamow, one of the biggest people in the field, biggest physicists of the field at the time, and just saying, hey, can we be friends? Yeah. She was not afraid of just walking up and taking what she needed and running with it. But also what I found in your book that really fascinated me, and again I've never come across, was that you showed her willingness to not only take credit that was due to her, but make sure that anybody else around her that was due credit got it too. And, you know, so you really do tell the story of Kent Ford, who was one of her longtime collaborators and helped her do these flat rotation curves. You know, you tell the story about how when everyone was going crazy for her having discovered them, she says, well, actually the radio astronomers kind of found it first. It's just that nobody trusts a radio astronomer. You know, and so I mean, I'd never heard of that side of her personality, and it added this wonderful new dimension to her. And I think it's the fact that you really brought that out and weren't tempted to go the easy route, and yeah, say that she was a wonder gal and she did it for the first time.
Yeah, I mean, I think that again comes from some of the feedback that I got on the proposal, and just having different conversations with people and having them point that out to me, that, you know, she was very cognizant of other people that contributed and how her work fit in that way. So I think that does come up as you read more about her, and if you do read some of the papers where she does say, you know, I have to say that radio astronomers have done this first. And that was actually part of the reason that she went over to the Department of Terrestrial Magnetism in the 60s, because radio astronomers were doing this type of work that she wanted to do there. And so there was this question of, would she work with the radio astronomers in kind of that wavelength, or would she stay kind of in the visible light? And the story I like to tell from the quote from Kent Ford that I just love when I got to talk to him is, he just said, she moved in and she never moved out.
Oh my God, that's amazing.
Yeah.
And you know, to actually recognize radio at that time, for anybody that's not familiar with the history of radio, I am a radio astronomer. And the history of radio is that nobody even considered it radio astronomy for a very long time. It was called radio engineering. And radio astronomy was just like, okay, you can mess about with what you want, but whatever you find, we won't trust. And so the fact that she was actually willing to go over to something that even in those times was still in its infancy, again, shows a huge amount about her curiosity and her willing to very carefully consider things. I have no doubt that she spent many an evening considering where she was going. And I love to think that, you know what, I think there's a quote, is it a quote or something that you say directly, where she says she moved into a field because it was quiet, because she didn't like lots of people just bothering her all the time with questions about what she was doing. And I think a move into a radio astronomy world was probably a very good move, actually, to understand that data at least and consider it.
Yeah. I mean, the work she was doing when she was getting all of that chatter was really on quasars, which kind of blew up in that time as everybody wanted the farthest one, and they wanted to know what they were, and did it mean that the universe was really big? And so she, because she was so careful and so meticulous and so concerned about making a mistake, and didn't get to the telescope as often as other researchers, she just said, I can't do this the way I want to do it. I can't do it with the rigor that I would want to do it. And so I do want to move into something more quiet. And that's when she kind of made that turn to go look at stars and galaxies and measure how quickly they spun around the center of the galaxy. And so that was that decision. just because I guess the quasar field was getting a little overwhelming and competitive
as
and
it
intense.
Still is. That's never stopped.
Yes.
It's never stopped.
Yeah. But I was curious, if I could ask you a question. I was curious how you first came to know about Vera, and if that influenced your work at all, since you did say you became so excited about dark matter that you went on to study it.
Yeah, this is a super embarrassing question, so thanks for asking that.
Sorry.
Yeah, so I am somebody that cannot stand not understanding something, and so when I picked a book off the shelf about special relativity when I was about 16, I thought it was on the science fiction shelf, and I read about this and I understood about 1% of it, but it was like, oh my god, you know, time can get slower the faster you move, and it blew my mind so much that I went to university to study it. And then I went into cosmology. I was like, dark matter. Blew my mind. I was like, well, I've got to be a cosmologist then. I'm not going to be a condensed matter physicist. And so I ended up writing my master's thesis on dark matter. And when I remember this vividly, I sat down in the library. I've never been someone to go on the internet first. I will go to the library and I will get all of these things. And I'll surround myself by books. I sat down and I was like, right, who was the person that you know, discovered dark matter? I was like, oh, somebody called Vera Rubin. And I was shocked later on to find out that Vera Rubin was a woman. I had so internalized the fact that it was men that led my field, and I don't think I'd come across a woman's name at that point. So even Carolyn Herschel, you know, there's plenty if you look. I just hadn't come across it, and I've never really stopped serving that penance. You know, I really think that's why I do a lot of my gender equality work, to apologize to Vera Rubin. Yeah, and she fascinates me. She still fascinates me, and that's why I was when I got the email to review your book for Physics World, I was like, oh my god, yeah. I mean, A, free book, but B, Vera Rubin. Like I get to learn something more about somebody who I hesitate to use the word role model. It's not something I'm a fan of, but to learn something about how she was a name that was celebrated at the time, because that's rare. I do read and write a lot about scientists that are women now, and what you often find is you do have to dig them up. They are hidden figures. Vera Rubin was celebrated in her day. That's rare. So she really must have either done something incredible or pushed for recognition, and I think it was both. And so that's how I came to find out about her and continue to be very inspired. Actually.
Well, and tell me a little bit about dark matter, and then how that connects to your book on the first stars.
This is an interesting one. So directly, we think that dark matter has a very minimal role in terms of creating the first stars themselves, though actually there's more and more research that's coming along to suggest that it could change the size of them by the dark matter interacting with itself, is what's called annihilation. So they literally, these two things come together and they're like, we can't both exist. It's very strange, but so this provides an energy that can produce larger stars. Now this is at the very forefront, but what of course does contribute to it is that dark matter has a very significant role in the structure of the universe. So it's a huge part of the universe, you know, let's say a quarter of the matter in the universe for fun's sake, and that was around since after the Big Bang. And so it creates this web of structure, and it really is a gorgeous image. So everybody look up the web of dark matter. It literally is this gorgeous spider web, 3D spider web, and these create the the areas which are most likely to form stars, because they've got most of the stuff in, all of the gas gathers there because everything else is there basically through gravity. So that's where you get the first stars. So dark matter really, it forms a foundation upon which and where these first stars form. And now we're looking at whether it goes even further and helps form how they were shaped and when they were shaped. So it's, you know, dark matter influences everything in cosmology. You cannot get away from it. So understanding it from the 1960s was absolutely necessary, and you can kind of get a sense of how big a discovery this was for when Vera Rubin proved it. Dark matter, the thought of dark matter, as she says, goes quite far back. I was reading a really recent paper, oh my God, was it by Oort in like 1927? I think it's that paper. And he says, oh, there must be dark matter. And he uses it in the phrase of, you know, some stuff that's dark.
Yeah.
So the ideas were there, but she proved it beyond doubt. And that's where the perseverance comes in. I think most people would have walked away for the decade she was shoving these plots in people's faces.
Yeah, no, absolutely. And then the number of times that astronomers just said, no, that's not right, or that's just an anomaly there, and then for her to go and just, you know, go from 10 to 20 to 30 to hundreds of galaxies that all have this oddity of fast stars. I think that's really where astronomers had to stop and say, okay, wait a minute, okay, we need to rethink this.
I can't remember, I don't know whether you'll know this off by heart, but what was the number when people took her seriously, really?
She had a paper in the late 1970s, and I think she was at about 100 galaxies there. You know, that might not be exactly right.
Yeah. No, I just want a feeling of whether it was 16. Or,
no, yeah,
no, it was a lot more. That's shocking, isn't it?
Yeah,
that is shocking. So I'm just trying to eject my my super duper hard drive thing, because it's making a lot of beep pop. I'm R2D2. So ignore that. So when you look back, I'm imagining, as an author myself, I'm imagining that this book is actually quite far in your past now in terms of writing the end. I'm imagining it's more than a year, something like that.
Yes, you are correct. Yeah, now that I think about it.
What is the story, the fact, the feeling that remains with you now, the most potent one, I guess?
Oh, I would have to say, and this is probably a bit sad, but one of the things that I remembered in terms of the research for the book, and I really struggled with the ending of, how do I tie this all together? How do I really make people feel like she was a person that was loved and that other people really spent time with and appreciated, not necessarily for her scientific brain, but for just who she was. And I was trying to figure out how to put all that together. And my mentor, who had first introduced me to Vera, said, well, why don't you call her sister? She's still alive, and maybe she'd be willing to talk to you. And again, being my nervous self, I was like, well, I don't know. I mean, am I worthy to talk to her sister? I don't know. Finally, I just sent her an email, and she was just as lovely as Vera in responding. And we had this really heartfelt chat. And the kind of scene that she laid out for me was going to see Vera for the last time. And she had called and said, you know, I'm coming to see you. At that time, Vera was up in Princeton. and said, you know, I'm coming to see you. I can't wait. I'm super excited. And Vera said the same. And her sister got to the facility where Vera was staying and walked up to her. And Vera said to her, "Who are you? I'm waiting for my sister." And it was this moment where you really felt how painful dementia can be, because one of Vera's biggest fears was losing her memory and losing her ability to think critically and to really think about the galaxies that she loves so much and think about the people that she loves so much. And when her sister told me that story, even, you know, years later, you could hear her voice crack, because there was just, you know, so much love for her sister, and the fact that she didn't remember her was just heartbreaking. And I still keep that phone call in my mind, just as, you know, something that was so touching, because you can think of an astronomer as this very distant 2D kind of awe-inspiring figure and forget that they are a person, a human being with feelings and emotions and siblings and children. And that was just something that really hit home for me. And I wanted to include that to kind of encapsulate the idea that she was really this incredible human being, not just an astronomer.
Really touching. Thank you for sharing that. And it's an everyday reminder, isn't it, of valuing the things that you do. And I think that's something that she did. You know, she really did every day just do what she loved. And yeah, oh gosh, I had something that span off that and I didn't write it down, so it's really annoying. So I will, did I not write it? No, okay, never mind. So you share that really poignant moment, and you say about how, you know, she is 3D, and what and I make this mistake myself, but a lot of people say woman scientist, and a lot of people say that, including myself sometimes. And I think in the way you've just described, you know, even describing that she had sisters and children and loves, and I think she went part-time at some point, didn't she, to help with the children that she had birthed. Yeah, and that all comes down to it really, is that she wasn't a woman scientist, she was a scientist who was a woman. And you know, I think that's true today. Like, I'm often described as woman scientist Emma Chapman whenever I'm introduced on the media or anything, and it's like, actually, I'm a woman that does science. Yeah. Like, you wouldn't say, you know, man scientist.
Yeah. Exactly,
because it's putting my gender first. And this is something that I mean, I adored in your book, and I think I like this really came through in my review. I was like fangirling this, was that you wrote her story and the story of dark matter weft, I don't know, let's say weaved together. And of course you mentioned the moments that her gender provided an obstacle, like the fact that they wouldn't let her observe it, is it Palomar, because the toilet just said men.
Yeah.
And you're like, well, what can we do? We can't remove this sign. And then later, you know, she said, this is ridiculous, I'm coming in. Yeah, and what fascinated me was that you left a chapter right at the end that, oh my gosh, I'm not sure if I can even find it very quickly, and you might remember the title off by heart, but it was it was about gender. I might not find it. Yeah, okay, thank you. Gender equality in astronomy, a darker universe. And you put it right at the back. And this is something, again, that I've not seen, and it is something that says, scientist who is a woman. And, you know, that's how I really physically saw it. And I loved it, because most people do it the other way around. Most people do it with, she had so many obstacles, and look what she achieved despite that. You're like, no, you can bog off. You know, she was strong, and she achieved what she did because she was an incredible scientist. And yes, it is necessary to discuss the obstacles. It really is, because it formed part of her life.
Absolutely.
But it wasn't her life. It wasn't her life. And so by putting that discussion at the end, I think you really underline that. And yeah, I'm still fangirling that choice. Was that a choice that you intuitively made, or did it come to you through writing the book out of interest?
I think it came out in a lot of discussions, again, with my mentor, David Dworkin. He was instrumental in helping me shape this book, in trying to, I guess, figure out where do we have that conversation, because it needs to be in there. But like you said, it is not the conversation. It's a part of the conversation. And so I think what we ultimately decided was, let's get everyone excited about the work and the research and the beauty of the science. And then we can talk about what she did also in terms of obstacles and trying to make things better for people.
Yeah, that's really interesting. I can't help but think of Cecilia Payne-Gaposchkin when I talk about this, who was another incredible scientist who was a woman.
Right.
See, I'm so ingrained, I have to make myself say it very carefully. And again, if you read about her science is just incredible, but she's always portrayed as a woman scientist, as look at what she's achieved, even though she had to wear a corset. And yeah, it's really nice that you've had the chance to bring somebody out in a very different way. So I guess I have one more question that I'd written down, at least, and I'm sure I chat till cows come home, so I'm sure it will branch off others. But your job at the moment, what exactly is it? What is your job title at the moment? You work for science, and you're a freelance science writer, but do you also work as a permanent science writer at the publication you work at?
Yeah, so currently I'm at a magazine called Science News. And this was founded about 100 years ago. We just celebrated our 100-year anniversary. And the idea of the happy birthday to Science News. The idea of this magazine is really to share science with the public and get them excited about all types of discoveries. I mean, I kind of lean toward physics and astronomy because I don't know, that's where my passion lies. But we cover all subjects, and right now I work as a news editor. So essentially we're taking in all of the news and trying to figure out what's the most important for the general public to know. And obviously right now a lot of it is focused on the pandemic, but we're constantly looking, whether it's in space or physics or material science or earth science, climate science, just what's the pulse of the research right now. And how does that fit into the broader context of research? What do people need to know about right now? So we kind of are doing those little baby steps of progress in research. And there actually were stories about dark matter in our archives that were fun to explore. So, yeah.
Do you keep things on hold? Do you have a little folder of things that were really interesting, but damn COVID,
yes,
you couldn't kind of produce? And do you have ideas that could be a feature at least later on? Is that something you keep in the back of your mind?
Yeah, I have to admit my computer is probably a mess, but I have like little post-it notes and notes and notes in email and notes in a Word document and files all over my computer of all of just these different threads. Like if I read something, I'm like, oh, that's really interesting. That fits with this topic that I've been following. So let me file that away in there. So yeah, we do try to kind of keep track, and then later on, we will be putting features together on different topics.
Cool. And why is it, you say physics and astronomy, you're kind of biased towards that, as you should be. Does that come from your thesis, or does it come from an earlier interest? Like, were you in your garden at 7 years old looking at the stars? You know, why isn't it digging up dinosaurs that fascinates you? Yeah,
that's a great question. I think it started maybe when I was a kid. My mom would always take us out to look at the stars, and she was really interested in the space program. She actually applied to be the teacher in space. And yeah, so she was always fascinated by the stars and fascinated by technology related to space. And we talked a lot about that as a kid. I remember doing that a lot as a kid. And then I actually didn't do very well in physics, which made me very mad. And so,
you know what, physics in schools is I mean, the whole thing should be rewritten in my because it's all and what it should be is special relativity, like not the seriousness of it, but any GCSE kid can do the equation for special relativity, and you've got time travel, you've got walking through walls, you've got, anyway, I'm sorry I interrupted you.
No,
you didn't do well at physics. Okay.
I didn't do well in physics, and it made me mad. Like I was like, I will understand this. So then that's kind of how I got into writing about it, because I figured if I could read it and figure out how to explain it to someone else, then maybe I had mastered it in some way. Not the mathematical part, but just the conceptual part of how cool and intriguing it was.
That's brilliant. That's really cool. So what's next?
Oh, I don't know. Lots of things. Lots of things. Lots of ideas rattling around in my brain.
So one might fall out through a conversation with someone, and yeah, cool. Yeah. Brilliant. Well, I look forward to anything that you do write, and I'll be following your writing. So
thank you.
So do I. Thank you so much, Ashley and Emma, for that wonderful conversation. I really enjoyed hearing about the sort of, as Emma called it, the 3D warm, nurturing version of Vera, and also about how unafraid she was to really ask for what she needed in her career. So it was such an interesting conversation, and thank you so much for entertaining us this evening, or if you're in the US, this afternoon. So we have some time for Q&A from the audience. I'm going to start with this one. Someone has said, could you talk about the many young students she inspired? Did you interview any of them?
I did. I mean, I didn't spend a considerable amount of time interviewing the students, but I did get some time to talk to different people who felt like she was a mentor. You know, I was able to talk to Sarah Seeger, who worked with her at the Department of Terrestrial Magnetism, and a couple others. And I think it seemed to be like they got the same sense I did, that when they sat down with her, they were a person and they were interesting, and it was all about, how can I help you with your goals? What can I do? And I know Vera spent a lot of time writing letters of recommendation and nominating astronomers for awards, and really trying to spotlight these younger researchers' work and get them into positions where they could go on and do great things, and give them those opportunities. So I know she did spend a lot of time nurturing students, and even not just astronomers, but even young students. I can remember reading about an experience where she went to the Air and Space Museum, and she did an exercise with students where she was trying to teach them about how stars moved in the galaxy and what that meant for the existence of dark matter. And so she took the students down into the basement of the museum, and she had them kind of create a galaxy, and they were all stars in the galaxy, and some were closer in, some were farther apart, and they had to start to rotate, right? So they had to start to walk around. Well, the students farther out started to fall behind because, you know, they were kind of all walking at the same speed. And then she made them hold a rod and start walking. Well, the students farther out had to run to be able to stay up with the students closer in. And so what she was trying to show to them is like something else had to be pulling on those stars, something else had to be making them move faster. And so she kind of came up with all these fun ways of teaching what she had actually discovered.
That's such fun. I wish my physics classes had been like that. We have another question. Were you able to interview her children or meet her husband, Bob?
Yes, so I was able to interview her children. We corresponded a lot by email, which was excellent. They shared some very interesting stories. And then when I did that initial interview with her, with my mentor at the time, David Dvorkin, I was able to meet her husband. And that experience, I also tried to, I didn't get as much room in the book as I would have liked to kind of explain that dynamic between them. But even in that, I think it was an hour or two that we spent with them together, you could just see how much they loved and respected each other. They would finish each other's sentences and fill in stories where the other person dropped off. And just, it was, again, just a kind of a, something to aspire to in my own relationship in the future. So just that experience at 22 was incredible, because it was kind of this moment of teaching me how to be a gracious and kind, nurturing human being, and also what it was like to see a relationship like that had lasted so long and been so supportive of each other. I mean, I think the thing that I didn't get to say was really just how much Bob, her husband, was instrumental in her career and her success, in that he really made choices for his own career that supported hers. And, you know, he helped to watch the children when she went off to observe. And, you know, they were a partnership. And I think that's really, that was essential as well to being able, or for her to be able to do the work that she did.
That's so wonderful to hear. To what extent did Vera feel a responsibility to be a pioneer for women in science, for those who came after her? And did she see herself as a feminist?
Well, that's a good question. I think she did. I think I remember having a conversation with her sister again, and you know, the sister said something to the effect of being the second leading feminist in the family, inferring that Vera was the first. And so I think it was important for Vera to really try to set up opportunities for students to really recognize other women's research in the field. But again, not because they were women, but because they were doing great science. And so, yeah, I think, like I said before, she spent a lot of time writing letters of recommendation and being outspoken at different meetings that she would go to, especially like the National Academy of Sciences meeting. She would always stand up and say, well, what are we doing about equity? And then also kind of looking at the numbers. There was some research she did in the 1970s with a group of other women where they did a breakdown of the number of women who had PhDs, the number of women who had masters, what they were getting paid relative to their male counterparts, how they were getting jobs, how they were perceived, what awards they were winning. And some of that went on to shape awards that were given, and then, you know, leadership within some of these societies for astronomy and science itself.
Emma, I was wondering if you could talk a bit more about the history of dark matter. I was really interested when you mentioned that it was first written about I think you said in the 17th century?
Oh gosh. Yeah.
Sorry if I put you on the spot.
Yeah, no, you're
Another
going
question.
back now. What was I doing then? Oh goodness me. Yeah, I mean, to some extent, people were noticing that the stars were moving in a way that they hadn't expected, that were a little bit iffy, even if they couldn't pin down that they were much faster. But it really came to the point of when you have Jan Oort in the, have I frozen? They look like I've frozen. No, there we go. In the 1920s, when, you know, he said, look, we're looking at all this radio data, and we can see what he was doing was he was measuring the velocity of gas clouds. And he noticed that the velocity of the gas clouds were faster on the outer edges of the Milky Way, and that was very, you know, that was strange, but didn't really take it any further, because at the time there were sorry, he didn't measure it, did he? Sorry, you put me on the spot there. He theorized it, and then it was later, sorry, in the 1950s, I apologize, that they started to measure these gas clouds, and they started to measure that, and then that led very quickly on to Rubin's work, which is why Rubin's always said, well, actually the gas guys got there first. But you do find mentions of dark matter in, and please, Ashley, you'll be more familiar with the dates than me. It's like 1933, Zwicky, you know, he realized that these clusters of galaxies should be flying apart, and because you can calculate how they're held together by gravity, really they should have flung themselves apart. So there must be some dark mass that we can't see that's holding them together. But yeah, the history of dark matter as a concept goes back very far. The history as of an observational science is in its infancy still, and the idea of it being observed directly is very much still ongoing. It's something we haven't managed to do. It's something that goodness knows. But there's so much evidence that this stuff exists. There's very few people now that doubt it nowadays.
Thank you. Sorry for putting you on the spot, but I found that really interesting. So we have time for one last really quick question, if you could both answer briefly. What about other books by or about diverse voices in STEM? Next time you visit your favourite local bookstore, who would you like to see featured on the bookshelf? And that's to both of you.
Ooh. That's an excellent question. I think Emma's ready with an answer. She grabbed the book off the bookshelf already.
There's a few, if you're interested, and I'll put it in the chat. But Out of the Shadows is a mixture of a lot of scientists who were women. And what's really cool about it is that every single scientific, like everything they did in science, is prefaced with another scientist who is a woman, with why they think this person is incredible. And I believe both Vera Rubin is introduced by Robert Rubin, and I'm sure Vera Rubin does actually introduce somebody as well. But anyway, and then Cecilia Payne-Gaposchkin. I mean, this book is partly her autobiography, which she's hilarious. Like her humor is just like so sarcastic. So yeah, these are the two books that I would really recommend. Yeah.
And I would say one person that always sticks in my mind is Margaret Burbage, who was kind of instrumental in helping us understand stars and how stars grow and how that contributes to all the elements in the universe. And she was also someone that I know Vera looked up to. So that's always someone I would like to know more about, but just haven't gotten there yet.
I get her in Lego, which is always a good sign.
Yeah.
She's on my shelf somewhere. Yeah, I don't know how long the chat will stay live after this, but it'll be on my Twitter, which is Dr. E.O. Chapman. So I'll put those recommendations on there as well.
Great. Thank you so much to both of you for a really wonderful conversation and for giving up your time to give us this treat on a Tuesday in December.
Yeah.
We really appreciate it. And to the audience, if you'd like to find out more about Bright Galaxies, Dark Matter and Beyond, or any other MIT Press book, please see the link in the chat. And thank you very much for taking time out of your day to join. Thank you, Emma, to join us on Zoom today for this discussion. So thanks everyone, and goodbye.
Thank you so much.
Thank you so much.